Good day, everyone. So today I'm going to discuss about the resistors in series and parallel connections. Resistors is a component that has a resistance which has the ability to resist the flow of current, or it is the opposition to the flow of current. So resistors in series. So resistors are in series whenever the flow of charge or the current must flow through components sequentially. It means there is a single flow of current or path of a current to flow from positive to negative. The total resistance in series circuit is equal to the sum of the individual resistance since the current has to pass through each resistor in sequence through the circuit. So we can explain or we can elaborate the characteristic of a resistance in a series connection in a formula of total resistance is equals to resistor 1 or resistance 1 plus resistance 2 plus resistance 3 plus resistance 4 plus and so on. So this explains the characteristic of a resistance in a series circuit. The total resistance is equal to the sum of the individual resistances. So let's have an example. So suppose we have three resistors connected in series. R1 is equal to 200 ohms, R2 is equals to 100 ohms, and R3 is equals to 150 ohms. So we have the formula of total resistance is equals to R1 plus R2 plus R3. So you're going to substitute the value of each resistances. So RT, R1 is equals to 200, R2 is equals to 100, and R3 is equals to 150. So after substitution of your value, you're going to add or perform the operation addition. So 200 plus 100 is 300 plus 150. We have 450 ohms. So the total resistance of this figure is 450 ohms. Let's have another example. So we have here the four resistors connected in series. R1 is equals to 50 ohms. R2 is equals to 120 ohms. R3 is equals to 160 ohms. R4 is equals to 150 ohms. So we have the formula. Total resistance is equals to R1 plus R2 plus R3 plus R4. And then substitute the value of R1 to R4. We have here RT or total resistance is equals to 50, which is the value of R1, 120, which is the value of R2, 160 value of R3, then 150 value of R4. So 50 plus 120 is 170 plus 160. So that will be 330 plus 150. We have 480 ohms. The total resistance of these resistors connected in series is 480 ohms. Let's have another example. We have here the five resistors connected in series. So R1 is 75 ohms, R2 is 120 ohms, R3 is 90 ohms, R4 is 130 ohms, and R5 is 100 ohms. So again, we have the formula. RT is equals to R1 plus R2 plus R3 plus R4 and plus R5. Then we need to substitute the value. So R1 is 75 ohms, R2 is 120 ohms, R3 is 90 ohms, R4 is 130 ohms, and then R5 is equals to 100 ohms. And then perform the addition operation. So 75 plus 120 plus 90 plus 130 plus 100 is equals to 515 ohms. So the total resistance is 515 ohms. So that is how you compute the total resistance in a series circuit or series connection. What if the total resistance is given and one of the individual resistance is missing or the unknown? So same procedure you need to do. First, you need to substitute the value of each variables. So the total resistance is 600. So we have here 600. Then equals to R1 which is 200. Then R2 which is 100. And then R3. Then perform the operation of 200 plus 100 is equal to 300. So 600 is equals to 300 plus R3. And then you're going to move the 300 to the other side and then it will become negative. So 600 minus 300 is equals to R3. And then perform the operation. So 600 minus 300 is equal to 300 ohms. So the value of resistor 3 is 300 ohms. Let's have another example. So suppose the total resistance is 900 and the missing is or the unknown is R4 or the resistance of resistor 4. So same procedure. So we have the formula. Total resistance is equals to R1 plus R2 plus R3 plus R4 and plus R5. Then substitute the value of each given data. So the RT is or the total resistance is 900. R1 is 75. R2 is 120. R3 is 90. R4 is the unknown. And then R5 is 100. Then perform the operation for 75 plus 120 plus 90 and plus 100. And then we will have 900 is equals to 385 plus R4. Then you move the 385 to the other side and it becomes negative. So 900 minus 385 is equals to R4. Then 900 minus 385 is equal to 515 ohms. So R4 is equal to 515 ohms. That is how you compute the total resistance in resistor connected in series connection. Next, let us proceed now to the resistors in parallel. So resistors are in parallel when each resistor is connected directly to the voltage source by connecting wires having negligible resistance. Each resistor thus has the full voltage of the source applied to it. So it means the voltage in each resistor are equal to each other. So this is an example of our resistor connected in parallel. So there are 4 resistors connected in parallel. So each resistor draws the same current. It will if it is where the only resistor connected to the voltage source. This is true of the circuitry in a house or apartment. So the parallel connection is commonly used in household wiring or sa electrical installation. So each outlet that is connected to a appliance, the resistor, can operate independently, and the current does not have to pass through each appliance sequentially. So it means every appliance is not affected when one appliance is not working. So let us have an example of resistors in parallel. So in resistor connected in parallel, there are three formulas you are going to use. So first, if there are two resistors connected in parallel, so we're going to use this formula. The total resistance is equals to R1 times R2 divided by R1 plus R2. So this formula are we going to use when there is or there are two resistors connected in parallel. So let us have an example. So we have here two resistors connected in parallel. R1 is equal to 200 ohms. R2 is equals to 150 ohms. So again, substitute the value of the given data. So R1 is equals to 200 times R2 is equals to 150. Then divide by 200, which is the R1, and then plus R2, which is 150. And then we will have 30,000. 200 times 150 is equals to 30,000. And then 200 plus 150 is equal to 350. Then you're going to divide 30,000 by 350. We will get 85.71 ohms. So the total resistance is equal to 85.71 ohms. Let's have another example. So we have here R1 is equal to 20 ohms. R2 is equal to 10 ohms. So substitute the value. So 20, which is the R1, times the R2, which is 10, and then over R1 is 20 plus 10, which is the R2. Then 20 times 10 is 200, and then 20 plus 10 is equals to 30. Then 200 divided by 30, we will get 6.67 ohms. So the total resistance is equals to 6.67 ohms. Next, we have another example. So if there are two or more resistors connected in parallel and with the same value, we're going to use the formula total resistance is equals to the resistance divided by N, or the N is equal represent the total number of resistors connected in parallel. So R stands for the resistance. So let's have an example. So we have here three resistors connected in parallel. R1 is 150, R2 is 150, R3 is 150. So the three resistors connected in parallel have the same value of 150 ohms. Now let us substitute the value of each given data. So R is 150. So 150 is the resistance of each resistor. So 150 then over N. The N is the total number of resistors connected in parallel. So there are 3 resistors. So divide by 3. Then 150 divided by 3 is equal to 50 ohms. The total resistance is equals to 50 ohms. Next, let's have an example again. So we have here R1, R2, or R3 have the same value, which is 20 ohms. So again, substitute the value. So total resistance is equals to the R, which is 20, over N, which is 3. Then 20 divided by 3 is equal to 6.67. So the total resistance of this connection is 6.67 ohms. Next, we're going now to the third formula. So if there are two or more resistors connected in parallel, use this formula. No? This will be our formula. 1 over the total resistance is equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus so on and so forth. So, suppose we have here a 3 resistors connected in parallel. R1 is 20 ohms, R2 is 60 ohms, R3 is 80 ohms. So again, let's have substitute the value. So 1 over RT is equals to 1 over 20, which is the value of R1, plus 1 over 60, value of R2, plus 1 over 80, value of R3. Then 1 divided by 20 is equals to 0.05, plus 1 divided by 60 is equals to 0.0167, plus 1 over 80, which is 0.0125. Then perform the operation. So 0.05 plus 0.0167 plus 0.0125 is equals to 0.0792. Then after that, so you're going to move the numerator 1 to the other side, and then it will become RT is equals to 1 divided by 0.0792. And 1 divided by 0.0792 is equals to 12.63 ohms. So the total resistance is 12.63 ohms. Next example. So we have here R1 is equals to 200 ohms, R2 is equal to 100 ohms, and R3 is equals to 50 ohms. So substitute again the value. So 1 over 200, which is R1, plus 1 over 100, R2, plus 1 over 50, which is the R3. Then 1 divided by 200 is equals to 0.005. Then 1 over 100 is equals to 0.01. And 1 over 50 is equals to 0.02. Then perform the operation or the addition operation. So 1 over RT is equals to 0.035. And then move the numerator 1 to the other side. That will become RT is equals to 1 divided by 0.035. And then 1 divided by 0.035 is equals to 28.57 ohms. So the total resistance of the circuit is 28.57 ohms. In resistor connected in parallel, remember this. The total resistance must be lower than the smallest value of the resistor. Again, the total resistance of a resistors connected in parallel should be lower than the smallest value of the resistor. Like this one, on the first example, the lowest or the smallest value is 20 ohms. Then the total resistance is 12.63 ohms. And then on the second example, the lowest resistance is 50 ohms. Then the total resistance is 28.57 ohms. Alright? So that's all for today. Thank you for listening and God bless.